Hello everyone and welcome to week number 8. This week we probably have the most difficult chapters to really work with, but the nice thing is that you'll be working with these both in the online section as well as your lab section. So this week we're focusing on pharmacology and medication administration. So this week we're focusing on 3 chapters. We're looking at chapter 53, chapter 54, and chapter 55. So let's go ahead. We're going to start right in the middle here. We're going to start with chapter 54 today. So chapter 54 is looking at pharmacology, which is the study of medications and drugs, including their forms, intentions for use, and effects. Now, in Module 7, we talked about the classifications of drugs in your lab classes. We talked about the scheduling of drugs, but what we did not talk about was the drug names. Now, drug names typically have 3 different names. They are a generic name, a brand name, and a chemical name. A generic name is the official name of the drug. It is typically written in lowercase letters, and it's also called the legal name for the drug. A brand name is typically written with capitalized letters, and it's a name given to the drug by specific manufacturers. And the final piece is the chemical name. Now, this is a chemical formula used by manufacturers and pharmacists to make up the medication. So, for example, here I have the word acetaminophen. That's the generic name for the brand name of Tylenol. And the chemical name is N-acetamide. Also in week 7, you guys talked about how medications are administered. And the route of medication is the method by which a drug is introduced to the body. That could be orally, parenterally, sublingually, by inhalation, by topicals, by drops or suppositories. And I'm going to go more into detail with these when we talk about chapter 55. But for right now, I'm going to just leave that in your mind's eye to think about. Additionally, with chapter 54, you will be learning how to review and write prescriptions and understanding a prescription. Now, reading a prescription and writing it for the physician may be a task that you're asked to do, but please understand you cannot sign that order. That has to still happen by a physician. You must be able to understand the symbols, the prescription pad, and the abbreviations that can be used. It's important to understand the parts of a prescription, such as a superscription, inscription, subscription, sig or signia, and then the physician's address, name, phone number, and DEA number, as well as the number of refills and the dispense as written line. So let's look at some of these a little bit closer. So a superscription is the patient information, their name, their address, and their date of birth. An inscription is the medication or the name of the medication along with the dosage being ordered. A subscription is the amount of medication that the pharmacy is to dispense to the patient. The sig or signia are the instructions for how the medication is to be taken. The physician's name, address, and phone number I think makes sense to you, but maybe the part that doesn't is their DEA number. The DEA number is a Drug Enforcement Agency number assigned to physicians that states they are able to prescribe, dispense, and administer controlled substances. This does not have to be on all of the prescriptions. And the dispense's written line simply states whether or not a generic medication can be given to the patient or if it has to be a brand name only. All right, so we're going to move on now to chapter 53, which is the daunting part for this week, which is talking about the math for pharmacology. Now, I don't want you to panic. I know. I've been there. I know that something about math is extremely scary and you absolutely hate math, right? But this is very simple math. This is something we can all absolutely do, I promise you. Every quarter I have students telling me, oh, I can't do it. But they make it through, and when they're done, they're like, oh, that was so simple. That's totally easy. I can totally do that. Now, when we use math and pharmacology, what we're doing is calculating drug dosages. That will use addition and subtraction, multiplication and division, as well as fraction and decimals. Now, there are two calculation systems that we use to measure dosages. The first one is the apothecary, and the second is the metric. Now, an apothecary method really is not used here in the United States, but still something that you might want to look at. I'm not going to focus on it for the video. I'm going to focus on more the ones that we will be responsible for as medical assistants, okay? So the metric system is most commonly used for dose calculations and conversions. It uses the prefixes kilo, hecto, and deca. Then we have your base unit, deci, centi, milli, and micro. Metric conversions are accomplished by multiplying or dividing numbers by 1,000. And the most common metric units that we use for base units are liter, meter, and gram. Liter is referring to volume, gram is referring to weight, and meter is referring to length. In the metric system, dosages are written as decimal numbers first, then the unit of measurement. So for example, we have something like 25 milligrams. The number decimal is first, and then we have the unit behind it. All right, let's dive into the discussion on drug dose calculations. So many factors are involved when a physician calculates the correct dose of a drug, including, but not limited to, the patient's age, the patient's weight, the patient's current state of health, and any other medications that the patient is taking. The first step in any drug calculation is to confirm that the system of weights and measures are the same as the supply on hand. If they are different, you will need to do some sort of conversion. So for example, if my order read 25 grams, but on hand I had 50 milligram tablets, I would need to convert my order in grams to match what I have on supply, milligrams. I will say this week in your lab classes, you will be dealing with these in class. So I'm not going to go too far in advance. I really want you to be able to do this with your lab instructors as well. Now, when we start talking about methods, we use two methods for dose calculations. We either use the ratio method or the formula. The ratio method establishes a relationship between two quantities. It compares the drugs ordered to the amount on hand. Where the formula method uses a simple formula to determine the amount of drugs needed in the equation. That is the desired amount, or the amount ordered, divided by the dose on hand times the quantity of the supply on hand. Now I know, again, these are very confusing to understand, but a great deal of these will be more easily understood in your lab classes this week. So please make sure when you have questions about these formulas, you ask your lab instructors, as they are the ones really kind of digging into that, and your homework in your lab class will be based on these. Now, the last thing that I want to talk about for this chapter is going to be how you calculate drug dosages for pediatric patients. Pediatric medications and their dosages differ from that of adults for several reasons, but most commonly, they don't nearly weigh as much as we do as adults. And there are several rules that we need to follow in order to calculate these drug dosages for pediatrics. First and foremost, we have Clark's rule, and this is based on the child's weight and the amount of medication that is needed for that weight. This is the most common one that we will use in the United States. We also have Freed's Law, which applies to children under the age of 1. Young's Rule, which applies to children who are over 1. And the West nomogram, which uses the child's BSA or body surface area to calculate the appropriate dosage. All right, let's talk about our final chapter, which is chapter 55, and medication administration. And medications can be administered in several different forms, such as orally, where the medication is swallowed and enters the tissues through the GI tract, then absorbed into the circulatory system. These can be pills, syrups, or liquids. Or we can also have what we call sublingual or buccal. Sublingual is under the tongue and buccal is into the cheek area. Topical, which is used for dermal applications or mucosal applications, such as creams, ointments, lotions, or skin patches, as well as eye drops, ear drops, and nose drops, eye ointments, vaginal creams, rectal and vaginal suppositories, or sterile dew solutions. Okay? One thing that's really important when you're working with topical medications, if you are administering it, you need to make sure that you wear gloves so you don't absorb the medication yourself as the medical assistant. We have rectal medications and inhalation medications or inhalers, but we also have injections. Now, those are called parenteral. This means that they enter into the body outside of the GI tract. And the ways that you can administer a parenteral medication are intramuscularly, subcutaneously, or intradermally. Hopefully you have been practicing these in your lab classes so you have a better understanding of each of those. Another thing that we need to pay attention to are the 3 befores of medication administration, which simply state that you need to check your medication 3 times: before it's removed from a cabinet, before it's poured, drawn up, or administered, and before you replace it back in a cabinet. Along with doing the 3 befores, you need to make sure you have the 7 rights of drug administration, which are the right patient, the right drug or medication, the right route, the right time, the right documentation, and as always, the patients have a right to refuse. Last thing I want to talk about here are injectable medications. Now, we as medical assistants are responsible for administering injections. We can draw these up from vials, ampules, or pre-filled syringes, but we also have powder medications that we may need to reconstitute with a sterile water or diluent in order to make them a liquid. Vials can be either single dose or multi-dose. Typically they will be glass or plastic, and most often plastic is more preferred because it is safer, not only for you but also for the patient. Ampules are small sealed glass bottles that contain a single dose of medication. With them being glass and sealed, you will need to break the vial in order to use it. I always suggest that students use a cotton swab or an alcohol prep pad. And pre-filled syringes are just like they sound like. They're a syringe that already contains the amount of medication that you need in order to administer. All you will need to do is put a needle on it and you're good to go. Alright guys, that is all I have for Module 8 this week. This week you do have one discussion post which is looking at medication errors. So please make sure that you read all of the instructions for that very carefully. It does have some good detail that needs to be put into your work. You will need to complete your initial discussion post no later than Tuesday, August 22nd by midnight. You need to reply to at least one classmate no later than Saturday, August 26th by midnight. And no written assignments this week. You just have a quiz to follow up with, which is dealing with these 3 chapters. That will be due no later than Sunday, August 27th by midnight. It does have 20 multiple choice questions. Alright guys, as always, if you have any questions, comments, concerns, or anything that you want to run past me, please make sure that you're shooting me an email through the course messaging in Blackboard or giving me a direct call at the Rockford campus. And you can find my number on the course homepage in the top right-hand corner up by my photo. Have a wonderful week 8, guys, and I hope to see some good discussion boards and case studies come through. Bye, everybody.